Hi everyone. Today we will study rational functions, and we talked a little bit about rational functions earlier in the semester. So today we're going to go into much deeper in terms of levels in rational functions. Okay. All right. So let's look at the function we studied before, f of x or y equals 1 over x. And we talked about in terms of a domain. So the domain for this problem would be denominator x shouldn't be 0. And then when we put this in terms of a set notation, and here you have an x-axis, and here's the 0 that you shouldn't let x to be. And we also talked about how close to 0 can we get. Okay. First, let's write the domain down. So the domain is x should be all real numbers starting from negative infinity, stop right before 0, and jump over 0, pick up on the right side of 0, and go all the way to positive infinity. Okay, so we talked about how close can I get to 0 from the right, from the left. So we talked about from the right, maybe we can go 0.001. That's pretty close. From the left, and maybe we can go to maybe negative 0.001. So I try to get really close to 0, but never on top of 0. Okay. Now let me introduce terminologies. When you get really close to 0 from the left-hand side, we write x approaches 0. That tiny negative sign means left. And if you are approaching x from the right-hand side, we say x approach 0 from the right. So let me write a note for you. From right, from left. Okay, all right. So now, what about y values? And let's take the limit. Limit as x approach 0 from the left. And let's just take the name of the function, 1 over x. And I want to figure out what y values is going to be. And also, we are checking on y values of the function. And then we're coming close to 0 from the right-hand side. Okay, equals, now let's see. Sorry, 1 divided by negative 0.001, it's going to result a negative number. It's a very large number. A large number, we talked about it, called infinity. From the right-hand side, same concept. 1 divided by positive 0.001, it's going to result in a positive number, and it's a very large number, positive infinity. Now let's think about what do they mean in terms of a y value. Y value really, really negative and infinity. And I'm thinking about this way down. And the y value positive, really big, way up. Okay. So, and I'm going to put a tiny sketch on the side. So if you have xy axis, all right, so let's look at it again. you are coming to 0 from the right-hand side, but not really touching 0, just get really close, and the y value way up, shoot up to the sky. If you coming to 0 from your left-hand side, y value negative infinity, way down. Okay, all right, so now let me write your note here, new terminology. The y-axis, or you can also call it x equals 0, is called the vertical asymptote. Okay, so for vertical asymptote, how do we find it? Where denominator equals 0. That's how we found that vertical asymptote. And also notice, okay, constant divided by a tiny number equals either positive or negative huge number. Okay, all right. So what is a vertical asymptote again? Your graph will get really, really close to it, but will never touch it, never cross it. That is an asymptote. All right, so I'm going to change the direction that I'm looking at this problem, and let me separate this a little bit. Okay, the other extreme I want to look at is what happens to y value when x is really big? What happens to y value when x is a positive or negative infinity? Okay, all right, so let's start again. Same function, reciprocal function. Okay, and I want to find out what's y values when x goes to positive infinity way to the right, or when x goes to negative infinity way to the left. Right. So what's the y value? What do we do? And we are going to take a limit. So we're going to take the limit, and we want to go to x from the far left side, and the name of function is 1 over x. And I want to find out what the y value is. Again, for the same reason, we want to know the y value when I go to the way to the right side of the x-axis. Okay. All right. So maybe we can come up with some x numbers we can plug in that would be easier to look at. So what's a negative x value that's close to infinity? Just for the simplicity, maybe negative 1,000 on a huge number for x, but it's a positive number, positive infinity. Again, positive infinity way to the right, x close to negative 1,000 way to the left. Okay, all right, ladies and gents, 1 divided by negative 1,000, it's going to be 0.00, and you don't need to write the negative sign on the 0, but I myself, you know me, OCD, so I usually put a negative on the 0, but you don't have to. Okay, all right, 1 divided by positive 1,000, a really, really tiny number, but that's a positive. Okay, so now let's summarize. Okay, and I'm going to put a tiny graph underneath. I'll just put it in between. I suppose that's good enough. Only look at the x-axis in this case, right? So, folks, when x goes to way to the right, and the y value, it's really close to 0, tiny small number, but it's positive. So somewhere, since the y is positive, you better stay above the x-axis. Okay. For the other reason, if you look at a y value way to the left side of x-axis, it's close to 0, and that's negative. How do I do negative y values? Under x-axis. That way. Okay, so now, ladies, gents, your graph gets really close to the x-axis, but never touch, never cross it. Your x-axis is called that's right, not vertical anymore, horizontal asymptote. Spell it out. The x-axis we can also call y equals to 0, is called the horizontal asymptote. Okay, where do I find it? Horizontal asymptote takes place where your x approaches way to the right, positive infinity, way left, negative infinity. Okay, and also notice, I have a little bit room here. Notice, maybe I write it up here. Okay, all right. Let me take this out. There's more room here. Notice, constant divided by huge number. Constant in all cases 1. Huge number, what kind of huge number? Negative 1,000, positive 1,000. And what's the result? Result in some kind of a 0, close to 0, either negative or positive 0. Okay, all right, so this is the introduction of vertical and horizontal asymptote. So what you need to focus on is the vertical asymptote, the horizontal asymptote. These are new concepts we haven't done before, and we have talked about how to sketch the curve of this very specific function before. Okay. All right, now I'm going to move on to the next part of today's lecture. Right before the very last class, I should have put it. The very last class, you and I met in person, and I did 1, 2 problems. Okay. And let's do the third one together today, just to think about how things were done when we had a face-to-face class. All right, so here it is. Let me sketch the graph again. Should I bring it down a bit? Okay, all right. So I didn't sketch out the whole graph, a rough sketch, and then we're hoping that you will just do it with me. Okay, all right. So I would like you to concentrate on looking at these two ends. Got very close to this vertical line. It got really close to this vertical line, but never touched it, never crossed it. So that vertical line is called a vertical asymptote. So here it is. X equals 2 is a vertical asymptote. Why is that? Why is that? Because your graph got really close to it, but never touched, never crossed it. All right. And also, this is the homework problem, number 29. Okay, all right. Then let's go forward with this problem. Okay, and then so again, oops, I moved this sheet of paper. Sorry about that. Okay, so x equals to 2 is a vertical asymptote. Okay, and on the other side, look at again. Here's a line, and the graph got really close to it, but never touched it, never crossed it. So here we have a second vertical asymptote, and that's x equals -2. So 2 vertical asymptote. Okay. And what else? And then we should look at the horizontal asymptote, which is right there. Okay. How do I know that's a horizontal asymptote? Look at our graph, got really close to it, but never touched it or never crossed it. So here we go. Therefore, y equals 1, this cross y equals 1, and the y equals 1 is called horizontal asymptote. Okay. All right, so I will just roughly repeat the sketches they provided for us. So I'm gonna close, connect. Just roughly. Not a good job, but that's okay. Okay. All right, so ladies and gents, I want to talk about these two and behaviors just now before anything else. Okay. All right, I want you to look at this end, and we want to find out with y going, with x going, follow me. We want to find out the limit of this function. I don't have the name of this function in details, so I just call it y equals. Okay. Underneath the limit, I want to write x gets close to what number from where. Nice and careful, look at it with me. X is getting closer and closer to this x number, which is -2. X gets really close to -2. And it's coming to -2 from the left-hand side. How do I do left? Tiny negative sign. Okay, again, x gets close to -2 from the left-hand side. What's the y value? Y shoot way up. That's positive infinity. At the meantime, maybe we should look at this end at the same time, this one. Okay. Why do I want to look at them as a pair? Because for the graph of this end, we are also coming to x-axis. We are also coming to x-axis close to -2. So again, come close to -2, come close to -2 in terms of x value. What's the difference? This time I'm coming to x equals -2 from the right-hand side. So your graph okay, so I'm going to write this end now. Follow me here. Limit of the function as x approaches -2 from the right, tiny positive sign, equals, look at your graph, drops way, way, way down, so that is negative infinity. Okay, all right. So now let me continue this. It passes, x-intercepts, you know all of that. I'm not going to bore you with this kind of information. Okay. Now I would like you to look at these two ends with me. All right, again, you notice these two ends are centered around the vertical asymptote x equals 2. This end, x equal to positive 2 rather. So these two ends is centered around the vertical asymptote x equals positive 2. What's the difference? For this one, I'm getting close to x equals positive 2 from my right hand, right? What about here? I'm getting close to x equal to 2 from my left hand, right limit, left limit. What number am I getting close to? X equals 2. Okay, let's write this out. Here we go. It's called end behavior. Limit, name a function, equals. Okay. Y value after the equal sign, way up in the sky, positive infinity. And let me start out x values, and you fill it in. I wait for you. Okay. And I'm going to look at this end. Again, it is the limit of the function equals. Again, this part you're really good at. I just know. Your y value drops way, way, way down to the earth. That's negative infinity. Again, go ahead, see if I can figure out x approaches what number from which side. X approach 2. X approach 2. What's the difference? One last time from the right. How do you do right? Tiny positive sign. From the left side of a positive 2. How do I indicate that? Tiny, tiny negative sign. Positive sign coming from the right. Tiny negative sign coming from the left. Right. So in this graph, they gave us 6 ends. So we did 4, and we need to do these 2. Okay. All right. So now you're looking at these 2. You notice these 2 ends is centered around your horizontal asymptote y equals 1. Let's lay them out. Limit of y value equals what? As x come from where? Okay. Also here, limit y value equals what as x approaches what number? All right, so let's see. This is where your x goes way, way, way to the right, which is a positive infinity. And that one, and when x goes way, way, way to the left, big old negative number, negative infinity. Not y value. Y value gets really close to this y value is 1. Okay, 1 and 1. And you notice they're both a little bit more than 1. Okay, I know you're like, Ms. B, do I need to know this? A little bit later. Right now, if you can see they get really close to 1, that's pretty good. Okay, I'm not going to nag you with positive or negative. Okay, all right, now we'll put this down. Now we are going to start preparation. So we can do all the wonderful problems I have asked for in terms of a homework. Okay, so this is the core of this section. And I would do a little bit of preparation in terms of how things work, and then we'll just go running with this type of problem. So first thing I want to do is I want you to look at number 55 with me, and we're just going to do one thing of finding horizontal asymptotes. Okay, all right. Let's go. I want to make sure I'm in the right space. So I'm going to find horizontal asymptotes. Okay, all right. follow me here. So I'm just going to do that one question on number 55. And homework, we were asked to do more than just finding horizontal asymptote, but I want to just single this part out and talk about it. Okay, so follow me. First step, you are going to divide x to the squared. You're like, why do I want to divide x to the squared? You just got to trust me here. X to the squared is the highest term in terms of this rational expression. So you are looking at the 5 terms in this rational expression. X to the squared happen to be the highest. So we're going to divide everything by x squared. Okay. All right. So I'm going to keep my fraction bar. I will write all the details out so later when you review it'll be easier. So first term divided by x squared. Just do it. We clean it up. Okay. All right. Now let me remind you one more time. Okay. We're looking for horizontal asymptote. With horizontal asymptote, it takes place where x approaches positive or negative infinity. Okay, so I need to find that out. Where's the y value when x approaches positive or negative infinity? So I usually use just to write h and a to stand for horizontal asymptote. Okay, all right, so I'm looking for y value, and the y value equals the limit of our function, whatever his name is, as x approaches positive or negative infinity equals. Okay. We've never done this before, so you just follow me, it will be fine. Okay, all right, here we go. First look, so we're going to check out on all 5 terms, and what you need to remember is constant divided by a huge number, it's going to be really close to 0. One more time. Constant divided by a huge number, it's going to get really close to 0. So log on to that part. Okay. All right, first you look at 2. 2 is not going to be bothered with wherever your x is, so 2 is just 2 plus. Now we go. 2 constant divided by x. X is a huge number. 2 divided by a huge number, really close to 0. Again, write your negative. Okay. What about 4 divided by huge numbers squared? Oh yeah, close to 0. Denominator, write your 1 since there's no x attached to it. Write your 1 plus 1 constant divided by a gigantic number close to 0 equals to 2. There we go. Y equals to 2 is the horizontal asymptote. Okay. All right. So where is it again? So you have xy axis. Horizontal asymptote is at y equals 1, 2. So you have a horizontal line. Okay. where your graph cannot touch, cannot touch, cannot pass, but we'll get really close to it. Not sure where, so either maybe above or below. We will check all that out a little bit later, okay? And on the left-hand side, it's the same. Your end of your graph is going to get really close to that y equals to 2. We still have to compute to see if it's coming from the top or from the bottom. Okay. All right, so that's just a preparation for us to find horizontal asymptote. Now I would like to do a problem from the beginning to the end and address all of those issues. Okay. All right, I'm going to take this down. Okay, deep breath. I want to do a problem from the beginning to the end. Put it here, and I'm going to do number 52. Again, as always, you know the very first problem of a new information is going to be super duper difficult. So every ounce of your hardworking self, bring that person forward. Give me all your discipline, your hardworking ethics, okay? And it will get easier once we've done 2-3 problems. Remember, it takes 3. First one is going to be very difficult, and be ready. Pardon. This is number 52. Function equals numerator, denominator, so I should like you to have 2 versions of this problem already, depending on what we are doing. So one version, leave it like this. Another version, would you factor the denominator? And we may as well write this is the y value. All right, so that's the preparation. Okay, and let's look at the problems and see what they want from us. They want intercepts, asymptotes, and then sketch. Oh, I have to write domain or range. Fine, fine, fine. Okay, all right, so let's do xy intercept. Pardon me. X-intercept, where y is 0. Y-intercept, where x is 0. Let's do x-intercept. So everybody, we are looking for x value when y equals 0. So you have, I have, let me lay a sheet of paper on top of this. Okay, all right. So basically you're looking for this function. And you want your y to be 0. So that means you have a 0 here. Okay. If you have a rational expression, the only way you can get to a 0 is when your numerator equals 0. So let's write this out. In order to solve x when y equals 0, your numerator of your rational function or your fraction has to be 0 for the result to be 0. So you're going to set x plus 2 equals 0, and then you want to write yourself a note that's numerator equals 0, and then we solve it. X plus 2 equals 0, x equal to -2. Okay. All right, what about y value when x equals 0, that should be a little bit easier. So when x is 0, numerator is 2. Denominator 0 plus 0 minus 3, so let's take a negative of negative 2/3. So x and y intercept. Nothing you don't already know. That's why I reviewed a little bit. When you have a rational expression equal to 0, numerator equals 0. Okay. All right. So we have 2 points already that we can put on our graphs. Now let's do horizontal asymptote. I will just use H and A. It's easier for me to write. Okay. Horizontal asymptote. Where does that take place again? Let's write our note to remind ourselves. Horizontal asymptote is a horizontal line. Therefore, it's y equals. Where does that take place again? When either x goes to the far right or far left. Far right, far left. And we want to look at the function value when x goes far right or far left. Okay, so just like the warm-up exercise, follow me, follow me. So first we divide and the highest term, and we don't usually go to the factored version, we go to the not factored version. And look at up and down, highest term among these 5 is x squared, so we divide x squared. Here we go. Grab our function. All 5 terms divided by x squared. Just do it. Reduce it. All right, now we go looking for horizontal asymptote. Okay, so horizontal asymptote, horizontal line y equals the limit of your function that's being rewritten into this format as x gets really big, whether positive or negative, equals 1 at a time. Ready? 1 constant divided by a gigantic number close to 0 plus 2 divided by gigantic number square close to 0. 1 is a constant, x has no impact on it. For the same token, 2 divided by huge number, 3 divided by huge number, so result is 0. So what does that mean? Where's your horizontal asymptote? Horizontal asymptote is at y equals 0. Y equals to 0 is also the x-axis. Okay. All right. Tiny sketch to illustrate the situation. So here is your horizontal asymptote, which is the x-axis. Okay. Your graph, when x comes to far right, your graph is going to hang either above or below. Gets really close to it, but won't touch it, won't cross it. When your x goes to the far left, the negative infinity, same. Your graph is going to get really close to the x-axis. I just don't know which one yet, either above or below, and then we will talk about that. So here we go. Horizontal asymptote is found. Now we're going to do the other asymptote, the vertical asymptote. Okay. And I myself, a super slow learner, I always write the definition again, that helps me to remember what I need to be doing. Okay. Vertical asymptote, where does that take place? Let's review what we have learned earlier. Vertical asymptote takes place where denominator equals 0. Vertical asymptote takes place where denominator is 0. Let me write this out. Denominator equals 0. And that is, you notice, closely associated to domain. So we may as well just spell out the domain right now. Okay, and let me use different color because it's the same concept here. Ladies, gents, domain is going to be set up as denominator not equal to 0, so that would be x plus 3 not equal to 0, x minus 1 not equal to 0. So the domain is going to be your x can just be anywhere it wants to be, just cannot be negative 3 and cannot be positive 1. And this is something we talked about at the very beginning of the semester. So your x can come all the way from the far left-hand side. And it's just going to have to stop before it hit negative 3 and pick up after you hopped over. Same reason for the positive 1. Okay, since it's convenient, we just write it. Domain is x is in the interval from negative infinity to negative 3. Jump over negative 3 that you cannot equal to, and the negative 3 to negative 1. Hop over negative 1, pick up from negative 1 to the right side all the way to infinity. That is your domain. Okay. So domain says your function cannot equal to these numbers. Therefore, we have the asymptote right there. So for asymptote, I know my graph cannot touch it, cannot cross it. I just want to know what my graph does when I get really close to these two numbers from the left and from the right. So let's do a little bit preparation just to see how we can look at the behavior of our graphs and around negative 3 and a positive 1. So let's lay this out. So this is the x-axis. And I'm going to look at them separately. Okay. What happens to my graph when I get close to negative 3? What happens to my graph when I get close to positive 1? And it's always easier to come up with some numbers. Okay, let me think about dollars and cents, just makes it really easy. When I come from the right side, and maybe I will look at a dollar and a penny. So this is slightly more than 1 from the right side. In terms of a limit notation, we write limit as x approaches 1. How do I do from the right side again? Tiny positive sign. Okay. What about from the left? What number? How about 1 penny less than $1? So that would be 99 cents. Okay. In limit notation, we are taking the limit of the function, and the x gets close to 1, but coming from the left-hand side, tiny negative sign. Let's prepare the same situation here. We are looking at the y value as x approaches negative 3. Let's write both out simultaneously, then fill in the details. Okay. All right, now what number is slightly more than owe people $3? And maybe you owe people $2.99. Okay, and that is getting close to -3 from the right-hand side to indicate right, tiny positive sign. Okay. How do I have slightly less money than owe people $3? Maybe I owe $3 and a penny. That's pretty close. And that is getting close to -3 from the left-hand side. Okay. All right, so what kind of answers do I expect? I can only take a guess here. I'm guessing that I either get close to -infinity or positive infinity. I don't know which one yet. And we'll find out. And also just remind you, when would you get to a situation like a negative or positive infinity? That must be you have a fraction, numerator is either positive or negative constant. And the denominator must be either positive or negative close to 0. And that's how you achieve negative or positive infinity, by taking a constant divided by really, really small number. Okay, all right, so this is all laid out, and we just need to find out whether the graph goes up or down at these 4 ends. There are 4 ends here, and we want to find out. All right, so now let's go look at these situations. We are doing really well. We're doing really well. I know the first example is always very challenging. We're not familiar with it, and I promise you it will get better. It will get much, much better after a little while. Okay? All right, I'm here for you. Let's go look at the function. This is going to be a little bit intense, so be prepared. Okay. And then I will spend more time talking about the first one. We're coming to -3 from the left-hand side of the function. I'm going to write that right limit at the same time so we can compare and contrast. Okay, name of function, factor the version preferred. All right, let me get your attention first. Okay, so there are 3 factors here. There's a key player. Look at the limit. What number am I interested in? Something about -3. Again, look to see where -3 comes from. It came from this factor, so we're going to keep our eyes glued onto that one. Okay, why is that? Because these this factor under these 2 situations, it will get really close to 0, and what we really need is that sign. I want to know that 0 is positive or negative, because the sign impacts whether your infinity shoot up to the sky or infinity drops down to the earth, -infinity. Okay, so make sure we keep a close watch on the signs on these zeros. And what about these numbers? And they will just come off a constant. So this is my plan. I'm going to tell you what I'm going to do, then I'm going to do it. Okay, so these 2 factors, I will just use the plain old -3 because I don't think that's going to be anything weird. So I just use -3. And I will only use those crazy decimals under that key player parentheses of x plus 3. Okay, one more time. X plus 2, x minus 1, I will just use plain -3. And I will save the decimal for the x plus 3 because that's what I'm interested in zooming in here. Okay. Okay. One number what I use, for the left limit, I will use negative 3.01 because I prepared. Okay. For the right limit, I will use negative 2.99. Okay, follow me, let's just do it. The best way to learn this is just do it. What else? Equals, side by side. Okay, all right, so numerator x approach negative 3 didn't come from that factor, so I just use whole number. Okay, look at the parentheses x minus 1. Our vertical asymptote didn't come from that factor, so same, just use whole number. Okay. Now be careful, split up now. Okay, inside the parentheses, lock your eyes with it, plus 3, plus 3. Okay, all right, so again, every ounce of your attention now. Coming to negative 3 from the left-hand side, let's use this decimal we prepared. Coming to negative 3 from the right, use decimal we prepared. Pardon. Equals. All right, so do easy part first, negative 1, negative 4, and a 0 of some kind. Watch out, negative, watch out, positive. Okay, put everything together. I just need one sign now. 3 negative signs. Let's write a constant in numerator. Denominator gets close to 0. 2 negative signs. Result is positive. Some sort of constant in the numerator. Don't care. Not going to make any difference. However, denominator gets close to 0. Again. Everybody, constant divided by tiny, tiny number, big number. Constant divided by tiny, tiny, tiny number, a big number, but it's negative. Write the positive down. Last time, constant divided by tiny number, big number. Okay, all right, so now let's do the limit to find our vertical asymptote, the graph's behavior close to vertical asymptote. Let's do positive 1. And I will put all this together for you. Okay, just hang on for a second. I will take care of it. Just hang on for a second. So this is the behavior of your graph around x equals negative 3. And then now I want to look at the behavior of our graph close to 1, close to x equals 1. Again, get close to 1 from the left, gets close to 1 from the right. Okay, name of the function. X plus 2. Did 1 come from it? Nope, so don't pay attention. X plus 3. Did my 1 come from it? No. Easy going. Last parentheses. X minus 1. Did my 1 come from it? Oh, yes. So be super duper careful with it. Let me highlight it after I put it down. Okay, all right. So when you use numbers, we will use 1 for these two sets of parentheses, and we're going to get the difference of the left and the right into these two x positions. Okay, all right. So always know the key player, the one that will cause the difference. All right. Use 1. For x plus 3, again, 1 didn't come from it, use 1. Now I need you to be alert. Let's grab the detail we prepared earlier. Coming to 1 from the left-hand side, 99 cents. Close to 1 from the right side, dollar and a penny. Okay. And also be prepared to end up with a constant divided by tiny number. Okay. Here we go. Equals. Okay. This is a constant. You can write positive 3 or you can just write a positive constant if you want. Your choice. Positive 4, you can just write positive constant or write positive 4. But the key is to have that positive sign. Okay. All right, now the deal maker or breaker. Look at these two sets of parentheses. I know they will both come to something tiny, small, close to 0. I really need the sign from you. This is going to be a negative, and that's going to be a positive. Okay. Summarize. Result is altogether 1 negative sign, constant in the numerator, tiny number in the denominator. Second one, result is positive, constant in the numerator, and the tiny number 0 in the denominator. Constant divided by teeny tiny number is going to result in huge number. One last time, constant divided by tiny number is a very large number. Okay. Now I think we should put all this together and sketch the graph, shall we? Okay. Right, this is going to be exciting. Okay. So first, let's keep track of what we have here. Right. So we have horizontal asymptote at the x-axis. We have 2 vertical asymptote, x equals negative 3 and x equals positive 1. And then we also have some intercepts. All right. Again, the only way to learn this is just by doing it. So I know you are strong. You are powerful. We can do it. Don't be afraid. I'm here for you.
We should try to wrap it up because it's already an hour long.
3 minutes.
Okay.
Okay. Y-axis. Okay. All right. So horizontal asymptote is the x-axis. Vertical asymptote at x equals 1. and x equals -3. We pass through intercept -2, 0, and 0, -2/3. Okay, all right. So now let's put last piece of information there, and then we are done. Okay, all right. So we're going to come to -3. When we come to -3 from the left-hand side, we're going to go down. So we drop down. When we come to -3 from the right-hand side, we're going to go way up. For the same reason, now I'm looking at x equals 1. When I come to -1 from the left, go way down. Come to 1 from the right, go way up. Okay. And remember, we don't ever touch or cross the x-axis. Now let's put the horizontal asymptote into the picture, way to the right, way to the left, and then we don't cross that horizontal asymptote. Okay, all right, so ladies, gents, so I'm just going to connect, okay, and I will go way to the -infinity, but I'm not touching the horizontal asymptote. Same as here, follow me. So you're going to come down, and you're going to pass the intercept. Okay, and you're going to keep on passing the intercept. And then look, you have to drop down now. So bend. Okay, last one. Vertical asymptote, you get really close to it. And I need to get close to the horizontal asymptote, but remember the asymptote's definition, you never cross it, you never touch it, you just get really close. That's why this end doesn't drop below the x-axis, because you can't touch it. Okay. All right, so we're done for this problem. Thank you.